Hello friends, welcome to Mass Academy. In this video, we are discussing physics examination for grade 10 general, term 2, 2022. The figure shows, this is the first question. The figure shows a ball interacts with a table and with earth according to Newton's third law. Which of the following is an interaction pair? Interaction pair means action and reaction. So Newton's third law states that force AB, that is equal to minus of force BA. Here this subscriptum represent the agent and the system. If AB represent the force applied by object A on B, that will be equal to force applied by B on A in the opposite direction. If this is action, this is the reaction. When an object apply a force on the other object will apply an equal force on the first object in the opposite direction. This is Newton's third law. So here we have four choices given. So I will start with the fourth choice. In the fourth choice, in D, you can see here F ball on table means force applied by on table. And what is the reaction given here? Force applied by Earth's mass on table. So here you can see both the forces, the action and the reaction, are acting on the same object. Both the forces are acting on the table. So this is not a correct answer. Why? According to Newton's third law, forces must act on two different objects. If one force is acting on the table, then the other force must act on the ball. So we will check this one. Here force applied by table on ball, and here also force applied by table on Earth's mass. So here you can see the agent is the same, means agent means the object applying the force. So here the object which is applying the force is the table, and here also the object applying the force is the table. So this is also not correct. The object applying the force must be different. If one force is applied by the object A, then other force will be applied by object B. Choice B, force applied by Earth's mass on ball and force applied by Earth's mass on table. Here also you can see the same agent, right? Both the forces are applied by Earth's mass. That is not correct. And in the first choice here you can see force applied by Earth's mass on ball and force applied by ball on Earth's mass. When A apply a force on B, B applies an equal force on A. That is Newton's third law. So this is the correct answer. Let us move to the next question, question number 2. The displacement and forces in 2 dimensions. If net force acting on an object is decreased, what happens to its acceleration? So net force and acceleration, that is given by Newton's second law. Newton's second law states that the net force is equal to mass multiplied acceleration. From Newton's second law, or from this equation, we can write an equation for acceleration. Acceleration is equal to net force over mass. So what happens to acceleration when net force acting on an object decreases? When net force decreases, the acceleration will decrease, right? You can see here, whatever the quantity that is on the numerator decreases. So here the net force is in the numerator. When this net force decreases, acceleration will decrease. And if the quantity in the denominator decreases, then acceleration will increase. Means, for example, if the mass is decreasing, then acceleration will increase because mass is in the denominator of the equation of acceleration. So the question is, what happens to the acceleration of an object when net force acting on the object decreases? Our answer is the acceleration decreases. Question number 3 is, which of the following is not true about weightlessness? So what is weightlessness? Weightlessness is a condition where you feel no weight, means your apparent weight become equal to 0. So the question is, which one is not true? Which one is not true about weightlessness? So we have 4 choices here. So I will go to the last choice. Contact forces on the object equal to 0. Actually, that condition is called weightlessness. When you feel weightless, the contact force acting on you becomes 0. So this is not our answer, because we need what is not true during weightlessness. The scale reading is 0. When you feel weightlessness, the scale reading will be 0. So this is also not our answer. The apparent weight equal to 0. The apparent weight equal to 0, that is called weightlessness. So this is not our answer. Our answer is the weight actually equal to 0. See, when you feel weightless, when you feel that your weight is 0, your actual weight will not be 0. Your apparent weight becomes 0, because the weight you feel is the contact force acting on you, or we say the normal contact force acting on you. That is what you feel as your weight. So when you feel weightless, the contact force acting on you will be 0, but your actual weight, that is your mass multiplied the gravitational field strength, that will not be 0. Let us move to question number 4. The figure shows 3 vectors L, M and N. Which of the following is true? So here you can see L is one vector, N is another vector, and M you can see it is starting from here to here, means M is starting from the tail of the first vector to the head of the second vector. L plus N, that is equal to M, right? Yes. Why? Because in this you can see here M is the resultant vector. So what is M? M is the vector L plus vector N. M is the resultant, right? What is resultant? A resultant vector starts from the tail of the first vector, from here to the head of the second vector. So here M is the resultant, so we can write M is equal to L plus N, the sum of other 2 vectors. Now we are discussing question number 5. 2 dogs are pulling a sled carrying food packages. One dog pulls with a force of 40 Newton and the other pulls with a force of 60 Newton as shown in the figure. The mass of the sled and the package is 50 kilogram. What is the acceleration? Acceleration is given by Newton's second law. Acceleration of an object is always equal to net force divided by mass. So here 2 forces are pulling the sled in the same direction. So the total force acting along this direction, we need to add both the forces, the 40 Newton force and the 60 Newton force. When we add these 2 forces, the total force will be 100 Newton, and the mass of the sled and the packages is 50 kilogram. So 100 divided by 50, that is equal to 2. 2 meter per second squared, because meter per second squared is the unit of acceleration, the SI unit of acceleration. So 2 meter per second squared is the value of acceleration. So this is our correct answer, the choice A. Now we are discussing question number 6. Which of the following object is not in equilibrium? Which of the following object is not in equilibrium? So to answer this question, first you have to know what is the meaning of equilibrium. Equilibrium means the net force acting on an object equal to 0. Equilibrium is a state where net force acting on the object will be equal to 0. Or we will say if an object is in equilibrium, another name for the net force is resultant force. Resultant force acting on the object is equal to 0. Or we say if an object is in equilibrium, the forces are balanced. Forces acting on the object are balanced. So if the net force is equal to 0 or forces are balanced, the object will be at rest or the object will be moving at constant speed. So if the object is at rest or moving at a constant speed, what about the acceleration? Acceleration will be equal to 0. So if the forces are balanced or net force acting on the object is 0, we say the object is in equilibrium. If the object is in equilibrium, the acceleration of the object will be 0, which means the object will be either at rest or moving at a constant velocity. So that is the meaning of equilibrium. So if the object is not in equilibrium, which means the object will be accelerating. So a car moving in a constant acceleration, that is a statement if the object, that is a correct statement if the object is not in equilibrium. If any object is not in equilibrium, the object must have acceleration or the object must be accelerating. Let us discuss question number 7. The figure shows a box at a rest on table. There are 3 forces on the box, but the box is not moving. Which is the normal force? So in this question, I think the diagram is not complete. So this is the box, and if 3 forces are acting, one is you are applying an upward force Fa that I will label by F1, that is the force you are applying, F1, and the second force is the normal force that we will write F2, and the third force is the force of gravity that we will label as F3. So if this is the situation, then F2 represents the normal force. Normal force will be always acting in the upward direction. The next question is, what is the weight of a mass 15 kilogram box? What is the weight of 15 kilogram box? What is the equation to calculate weight? You can calculate weight using the equation weight is equal to mass multiplied g, right? Weight is mg. What is the value of g on the surface of Earth? G will be always equal to 9.8 or 9.81. So mass is 15, 15 multiplied 9.81, which equals 15 multiplied 9.81 equals 147.15. 147.15. What is the unit of weight? Weight is a force of gravity, right? So its unit will be always Newton. So 147 is the correct answer. Then we are discussing question number 9. The figure shows two forces acting on a motorbike. 650 Newton forward and 250 Newton backward. What is the net force acting on the motorbike? See, all the questions we have discussed up to here are very simple questions. If you can, here you can see in this diagram, there are two forces acting, a 650 Newton force and a 250 Newton force. Both are acting in the opposite directions. If two forces are acting in the opposite direction, to find the net force, you need to find the difference between the forces. So 650 minus 250, that is equal to 400. 400 Newton, to which direction is the resultant? Resultant force will be always along the direction of the greater force. So the resultant force is to the right side. So 400 Newton forward. A net force of 30 Newton accelerates a block at 6 meters per second squared. What is the mass of the block? So here what is given in this question? First we will write in solving every physics question, physics numerical problems, we write what is given in the question. So net force is given. How much is the net force? Net force is 30 Newton. So I will write net force is equal to 30 Newton. And the block accelerates at 6 meter per second squared. Acceleration is equal to 6 meter per second squared, and you need to calculate the mass of the object. Then you think which equation connect all the three terms? Yes, Newton's second law, which connect all these three terms, right? So I will write the Newton's second law, acceleration, that is equal to net force over mass. But I want to calculate a mass, so I will rewrite this equation for mass. Mass is equal to net force over acceleration. So net force is how much? Net force is 30, right? And acceleration is 6. 30 divided by 6, that is equal to 5. And unit of mass is kilogram. So 5 kilogram is my answer. See here, 5 kilogram we will select as our answer. Question number 11. A bucket of water with weight 50 Newton is pulled up using a rope. The bucket is moving at a constant velocity. Then what is the tension in the rope? So you can see here, the weight of the bucket is moving downward. The weight of the bucket is mg, and the tension acting in the rope, that is upward, right? Tension will be acting upward. So this is the tension. If an object is moving at a constant speed, which means net force is equal to 0. If any object is moving at a constant speed, or if the object is at rest, then net force is equal to 0. So here this object is moving at a constant speed, so net force is equal to 0, means the bucket is moving at a constant speed. Net force is 0, which means opposite forces are equal, that is tension will be equal to mg, because tension and mg are the two forces, they are acting in the opposite directions. So tension is equal to mg. And how to calculate tension? By calculating the weight you can calculate the tension. So tension is equal to mg. M is how much? Mg, the weight, right? The weight, that is equal to 50 Newton. 50 Newton is the weight of the bucket. So tension will be equal to weight. 50 Newton is the answer. Salim walks 60 meter east, then walks 80 meter south. What is the magnitude of his displacement? So I will draw here the directions. So if this is north, this will be south. And I write here V, west and east. So what is this question? Salim walks 60 meter east. So 60 meter east, he is first walking in this direction, 60 meter, then 80 meters south. 80 meters south. So what is the magnitude of his resultant displacement? Resultant displacement will be always from the starting point to the end, means from the tail of the first vector to the head of the second. So this is the resultant. So here you can see this first displacement and the second displacement, they are perpendicular, right? They make an angle 90 degree with each other. So if two displacements are perpendicular or two vectors are perpendicular, to calculate the resultant you will use Pythagorean theorem, square root of 60 squared plus 80 squared, which equals square root of 60 squared plus 80 squared equals 100. So 100 meter is the resultant displacement. 100 meter is the correct answer. Which of the following is a field force? There are two types of forces that you are studying: contact force and non-contact force. Another name for non-contact force is field force. So we can say you are studying two types of forces: contact force and field force. In contact force, or to apply a contact force, you need to touch that object. For example, if you want to move this table, you want to push the table, you need to touch the table. There must be a contact between your hand and the table. That is an example for contact force. Non-contact force means the force can be acted without there is a contact between the system and the agent. For example, magnetic force. Two magnets can attract each other or they can repel each other, means they can apply force between them without being in contact. Earth and Moon, the gravitational force between Earth and Moon. There is always a gravitational force between Earth and Moon, but they are not in contact. They are not touching each other. So gravitational field, electrostatic force. So gravitational force, electrostatic force, magnetic force, all these types of forces are example for non-contact force. So here our answer is gravitational force. So gravitational force is a field force. Next question. A block is resting on a rough surface. The coefficient of static friction between The block and the surface is 0.2. The normal force acting on the block is 50. What is the maximum static friction? The force, static friction force that the surface can exert. What is the equation to calculate the maximum value of static friction? Maximum value of static friction, which is equal to coefficient of friction multiplied normal force. So this is a very simple question. You need to apply the direct equation. Why? Because the coefficient of friction is given, the normal force also given. Coefficient of friction is equal to 0.2 multiplied normal force is 50. So the answer will be equal to 10 10 Newton. That is the value of the or maximum value of the static friction. 0.2 multiplied 50, that is equal to 10 Newton. Newton is the unit of force. So what is the equation to calculate static friction? Or to calculate any type of friction, the equation is coefficient of friction multiplied normal force. So 10 Newton is our answer. What is cause of all accelerations? The cause of acceleration is net force, resultant force, or unbalanced forces. These are same thing, okay, with a different name. Net force, resultant force, unbalanced forces. So this is the same thing, okay, different name. So this is the cause. Unbalanced force is the cause of all types of acceleration. A net force of 4000 Newton is acting on a car with a mass of 1600 kilogram. What is the acceleration? Very simple question. Acceleration, according to Newton's second law, acceleration is net force divided by mass. How much is the net force in the question? The net force in the question is 4000 Newton. So 4000 over mass. Mass is how much? 1600 kilogram. So 4000 divided by 1600, which equals 4000 divided by 1600 equal to 2.5. 2.5 meter per second squared is the value of acceleration. So if net force is given and you want to calculate acceleration, the equation is Newton's second law. Acceleration is equal to net force over mass of the object. We are discussing question number 17. Which of the following is the force exerted from one surface on the other when there is no motion between two surfaces? So when an object is moving over a surface, when an object is moving over a surface, there will be a frictional force acting. Or when an object is moving or tend to move over a surface, there will be frictional force acting. The friction acting when the object is not moving, that type of friction is called static friction. And the friction acting while the object is moving, that friction is called kinetic friction. So there are two types of friction, static friction and kinetic friction. Static friction means friction acting when the object is not moving, and kinetic friction is the friction acting when the object is moving. So here the answer to our question is static friction. When the object is not in motion, the friction between the surfaces is called static friction. Four forces are acting on a block as shown in the figure. what is the net force acting on the block. So here you can see these two forces 10 Newton and this 10 Newton, they are equal and opposite. So they cancel each other, they balances each other. So what are the two forces remaining? This 15 Newton force and 7 Newton force, they are acting in the opposite directions. So to find the net force, the larger force minus the smaller force if there are two forces acting in the opposite direction. So 15 minus 7, that is equal to 8 Newton upward, right? Because the upward force is the greater force, 8 Newton up. Question number 19. The figure shows the free body diagram of a suitcase resting on a rough inclined plane. There are only three forces acting on the suitcase as shown in the figure. Which of the force is the friction force acting on the suitcase? So here the suitcase has a tendency to move down, right? So frictional force will be always act along the opposite to the direction of motion. So the box has a tendency to slide down the inclined plane. So the frictional force will be acting in the opposite direction. So F2 is the direction of the frictional force. A man with a weight of 650 Newton is standing on a scale in an elevator. The elevator is moving up a constant speed. Which of the following is the correct reading on the scale? So here, the scale reading that we will represent by R, the reaction force, or it is called the normal reaction. So I will represent the scale reading by the normal contact force, Fn. So this is the scale reading. When you stand on a scale to measure your weight, the reading on the scale will be the normal contact force acting on you. That is why the scale reading here I am representing by the normal force acting on you. So we have three different situations. Number one is if the elevator is at rest or moving at a constant speed, then the scale reading that will be equal to your weight mg when the elevator is at rest or moving at a constant speed. Another one situation, the second situation is the elevator is accelerating up. If the elevator is accelerating up, the normal force or scale reading will be equal to mg plus ma, where m is the mass and a is the acceleration of the elevator when the elevator is accelerating up. And third one is when the elevator is accelerating down, the scale reading will be less than your actual weight, that is mg minus ma, when the elevator is accelerating downward. So you can see when the elevator is at rest or moving at a constant speed, the scale reading will be equal to your actual weight. Second, when the elevator is accelerating in the upward direction, then the scale reading will be greater than your actual weight. This m is mass, means your mass, and a is the acceleration of the elevator. And when the elevator is accelerating downward, the scale reading will be less than your actual weight. So here your actual weight is 650 Newton and the elevator is moving at a constant speed. So the scale reading will be same as your weight, that is 650 Newton. Scale reading is also called the apparent weight. So here when the elevator is at rest or moving at a constant speed, apparent weight is equal to actual weight. The graph shows the relationship between force acting on the cart and its acceleration. What is the mass of the cart? So here the graph is not clear. This is a acceleration against a force graph. So if you calculate slope, you will get a 1 by mass, because this is a acceleration against force graph, right? So slope is equal to y by x. So y will be acceleration, x will be net force. So if you calculate the slope, it is acceleration over net force. Acceleration over net force, that is equal to 1 over mass. So if you want to calculate mass, mass will be equal to 1 over slope. A skydiver of weight 700 Newton falls with a terminal speed after opening his parachute. What is the drag force acting on the skydiver? All the questions are very easy. So this is his weight and the drag force will be acting up. The skydiver is moving with a terminal speed. Terminal speed means constant speed. If an object is moving at a constant speed, always the opposite forces will be equal, which means the drag force that is equal to the opposite force, that is weight is the opposite force of drag force. So drag force that is equal to weight of the skydiver, that is equal to 700 Newton. Weight is acting down, so drag force will be acting up. Question number 23. A vector that is equal to 20 Newton makes an angle 60 with a negative x-axis as shown in the figure. What is the component of R parallel to the x-axis? So what is this component? So we always take angle from the positive x-axis. So if we take angle from positive x-axis, the total angle is 180. So 180 minus 60, this will be 120 degree, right? So the x component Rx will be R cos 120. So R cos 120, that is the x component, and the value of R value of R is here, it is given here 20 Newton. So 20 multiplied cos 120 equals 20 multiplied cos 120, that equals negative 10. So negative 10 is the value of the x component. Which law states that acceleration of an object is proportional to net force and inversely proportional to mass of the object being accelerated? That is Newton's second law. Newton's second law states that acceleration is net force over mass, which means acceleration is directly proportional to net force and inversely proportional to the mass of the object. Question number 25, and this is the last question. Ahmed is pushing a wooden box with a weight of 500 Newton across a wooden floor at a constant speed. He exerts 200 Newton force. What is the coefficient of friction between the box and the floor? To calculate coefficient of friction, you must know what is the value of friction. So here you can see the block or the box which is moving at a constant speed. If any object is moving at a constant speed, the condition is opposite forces are equal. So force of friction, that is equal to 200 Newton. Why? Because force of friction and the applied forces are acting in the opposite direction. So frictional force, that is equal to 200 Newton. As the box is moving at a constant speed, frictional force and the applied force will be equal. So you got friction and you need to calculate the coefficient of friction. So coefficient, you have the equation for friction, force of friction, which is equal to coefficient of friction multiplied normal force. So you need to calculate coefficient of friction, right? Coefficient of friction mu, that is equal to force of friction divided by normal force. Force of friction is 200 Newton and normal force will be always equal to the weight of the object if the object is on a horizontal surface. The weight of this block is 500 Newton. So 200 divided by 500, that equals 0.4. 0.4 is the value of coefficient of friction. Coefficient of friction is a quantity which has no unit, and coefficient of friction will be always equal, always less than 1. So now we have discussed all the 25 questions from physics examination for grade 10 general term 2 2022. Thank you all my students and all my friends for watching this video. I want to request you to subscribe my channel, and I would like to wish you good luck and great success in your examination and in your life ahead. Thank you once again. Thank you very much.